So number 39, all they gave us was a function, and the instructions say, right, is a product of linear and irreducible quadratic factors with real coefficients. So they didn't even ask us to find zeros in this. That's kind of nice. Okay. So tell me about this function and its zeros. How many zeros are there? There are 3 zeros. And can you tell me how many of those zeros are real zeros? How many are real zeros? This is not a definitive answer, but at least one, right? It's not possible for all of them to be complex, right? Because complex always come in pairs, and this is as an odd number. So either there's one real zero or there are 3 real zeros, right? There's no way that there are 2 or 3, okay? So I'm going to guess there's probably one, but the way I'm going to find out is via the calculator. If I didn't have my calculator, then I would generate a P over Q list and I would churn through that P over Q list. This one, actually, the P over Q list would not be that bad because there's only 2 factors of 3 and only 2 factors of 2. So there's only 4 numbers on that list, plus or minus those. So I guess there's actually 8. It could be a pain, but we don't need to worry about it because we got good old calculators. So let me get this in here. You're going to need your calculators out later on this period. So if you don't have them out already, go ahead and get those fired up and ready to go. So I'm looking for 1 or potentially 3 x-intercepts. I'm only seeing 1. It appears to be at +1. Second calc value, we'll verify that. Yes. So we have a 0 at 1. So all I need to do then is, well, to factor that out. So I've got, and I can actually tell by looking at the graph, not only do I have a 0 at 1, but that's the only real 0 that I have. There are no other x-intercepts. So these other 2 are going to be imaginary. And based on the instructions, they want anything that's imaginary to be written as irreducible quadratics. So I don't even really care what these are. They didn't ask me for those. I'm going to factor this out. So I'll factor out the x minus 1 that I know is a factor. That should leave me with a quadratic. And that's going to be my answer. So let me factor this out. So I'm going to use synthetic division. 2, -1, 3, -3. I do expect to get a remainder of 0. Hey, I got my remainder of 0. And my remaining factor would be 2x squared plus 0x plus 3. And that would be my final answer. The one thing I forgot to do is check and make sure I don't need an a value out in front. My lead term here is 2x to the third, and this would also be 2x to the third, so we're okay. Any others you're dying to go over from the assignment? '23. See if you've done that one yet today. Nope. We'll do 23. Okay, from the same page. Wait, was this part of our assignment? State how many complex and how many real zeros of the function has. Okay. Let me write it down. X cubed minus x plus 3. So how many zeros do we have? There are 3 zeros because it's a 3rd degree polynomial, which means one of them has to be real. One of them is real or else all 3 of them are real. There's no way we could have 3 complex. We could have 2 complex. There's no way we could have 3 complex. So how are we going to know which ones are real and which ones are not? I'd say graph it. There's an x-intercept. That means it's a real 0. We can't need it in here. Sorry. So x cubed minus x plus 3. So what I'm seeing when I look at that is 1 real 0 because of that x-intercept. And then there's no other x-intercept, so there must be one real and two imaginary. Is that all they wanted? State how many complex and real zeros the function has. Yeah, that's it. Any other questions? Hmm? Yeah. I don't know. Did I mess it up? Where did I mess up? Oh, that should, wait a second. That's two times one. This should have been a two, shouldn't it? Oh, you totally screwed this up. Thanks for checking me here. All right, going too fast here. Let's try this again. 2 times 1 is 2. This should have been a 1 times 1 is 1. This just should have been a 4. Oh, I wrote it wrong too. Man, I made multiple mistakes and they didn't cancel each other out. It's terrible. All right, let's try this again. All right, so that makes this a 3. Okay, and this is a 3, and then we get, okay, so 2, 1, 3. So I'm sorry, it should have been 2x squared plus 1x plus 3 here instead. Thank you for that correction. And we don't need to go any further because I know that this is going to give me complex zeros. Other questions? Several people had questions about 27 today. If you did 27, the big common mistake with 27 was when you did the division, when you did the synthetic division to pull that 1 out, did you notice that you were missing an x squared in your original function? Did you put a 0 in for the synthetic division for that? That was the common error there. All right, we need to move on to our notes for today. So let's switch gears. If you haven't grabbed those, go ahead and grab them now. Before we